Hey guys, so in this video we are looking at how to use the calculator when you have multiple equations. And that could be systems of equations, it could be, we're just looking at parallel perpendicular. So I'm going to cover both of those. So this first question, for number 10 that you see on the screen, says what is the equation in slope-intercept form of the line that crosses the x-axis at 36 and is perpendicular to the line represented by y equals negative 4 over 9x plus 5. So your key points there, I have them circled and underlined, are it crosses the x-axis at 36. What that means is that is going to be your x-intercept. That is where the line is going to cross the x-axis at 36, this line that we're looking for. And it has to be perpendicular to the line that is given here. Now, perpendicular, if you don't remember, perpendicular means two lines or segments or objects that intersect at a 90-degree angle. So these two lines, for example, would be perpendicular because these are all 90-degree angles. That's what perpendicular means. So before we graph on the calculator, let's eliminate a couple of answers. Perpendicular lines have opposite reciprocal slopes. If you remember, this is y equals mx plus b right here. M is the slope of your line, b is your y-intercept. So we're focusing only on the slope. So what's the slope of the line that I have right now? The slope of the line that I have right now is negative 4 over 9. You can see that right there. I've somewhat circled it. Negative 4 over 9. So negative 4 over 9 is our slope. What we want to do is find a line that's perpendicular to that. Well, let's come down and do an example. Perpendicular. So opposite reciprocal means if one line has a slope of negative 3 over 4, the line that is perpendicular to it is going to be the opposite, which means instead of negative, it's going to be positive, and it's going to be the reciprocal, which means we flip it over. So instead of 3 over 4, it is 4 over 3. So that is how perpendicular lines work. So if you look back up here at the top, our original line is at negative 4 over 9. So I'll write that up here. Negative 4 over 9 is the original. So how do I get the perpendicular slope? Well, I'm going to take the opposite and the reciprocal. So what's the opposite of positive or negative? Positive. And then the reciprocal of 4 over 9 is 9 over 4. If you look at your answer choices, only these two answer choices have a slope of 9 over 4. Therefore, we can throw these out. Now we're ready to get moving on the calculator. So it's between these two guys. Let's go over to the calculator and let's start a graph. What I'm going to do is I'm going to graph both of these. Now, what is the criteria? The criteria is that it's perpendicular, which both of these are because they do have the opposite reciprocal slope. But it also has to do what? Cross the x-axis at 36. So I'm going to graph both of these guys and see which one of them crosses that x-axis at 36. So let's graph the first one. Y equals, so I have 9/4 x plus 81. And I'm going to graph that. Whoops, we can't see it. What you're going to do when something like this happens is you're going to go to your menu and you're going to go to Window or Zoom. The best thing to do is choose Zoom Fit. Now I can see my line. Well, if I see this line the way they've presented it in the window, I still can't see the x-axis. So I'm just going to have to do manual zooming. So I'm going to actually go to Window and I'm going to choose Zoom Out. You're going to get that little hourglass right there. You're going to keep clicking that little hourglass until you can actually see where the line crosses the y-axis. When you're done zooming out, hit Escape. Whoops, that's not what I wanted to do. I wanted to go back here to the graph, sorry. Hit Escape, and Escape will take you out of the zooming tool so that you're not constantly zooming out. Now, what we're going to do is we're going to see, does this graph cross at 36? This says to cross the x-axis at 36. Where is this line crossing? It's not crossing at positive 36, that's for sure. It's on a negative side. So you know it cannot be H. So our answer is going to be J. Just to show you how that works, first of all, if you were in a situation where it wasn't so obvious where it crossed, like we were looking for a positive 36 and this is negative, remember you can go to Menu and you can go to Analyze Graph and you can hit 0. Remember the zeros are where the graph crosses the x-axis? Well, my 0 is right there, so I'm going to give it a range. I know that my 0 is going to be in this range somewhere. It doesn't matter as long as the 0's in there. What is your 0 here? Negative 36. We're looking for a 0 of 36. Just to verify that we're doing this correctly, then you're going to go to Graph, Function. Let's now graph the other one. 9/4, so I'm graphing J. X minus 81. And that one is here. And you can move your graph, you can drag, you can press down. So let's find out what the 0 is here. I'm going to click on the red line because that's the one I'm looking at. Make sure it's blinking. That means you're focused on that line because that's my new equation. I'm going to go to Analyze Graph, go to 0. Oops. There we go. I know my 0's right there, so I'm going to make sure that my range surrounds it. And if you look there, your 0 is at 36, which is what we're looking for where it crosses the x-axis. So we eliminated those two values based on what a perpendicular slope is. And then we graphed in the calculator to check and see which one actually crossed at 36. If you want to do this by hand and do this the long way, what you would do is the y coordinate at the x-intercept is 0. You could plug in 0 for y, 36 for x, and see if you get something that works. But the graphing is the easiest way to do this so that you can see it. So that's an example of perpendicular. So let's move on here. And I know there's another question that deals with parallels, so we will try to hit that one next. Let me scroll up and find it. There's so many questions on this test, and we're looking for parallel. I know it's in here somewhere. And once we do that, I'm going to go back and show you how to solve some systems of equations like the one we just passed in the graph. But I wanted to hit parallel and perpendicular first because here we go, number 45. All right, so here's number 45. I'm going to pull up at the top. What is the equation in slope-intercept form of a line that passes through the point 50 and is parallel to the line y equals 1.2x plus 3.8? Now remember, perpendicular we just talked about is opposite reciprocal slopes. Again, we're looking at y equals mx plus b. M is your slope, that's your focus. The slope of the line here is 1.2, and I can't circle very well. So the slope of the line here is 1.2. Parallel. Parallel means that the slopes are exactly the same. So since this slope, this m, this is slope, remember, these are all slopes. Since that slope is 1.2 and we're looking for parallel, we're looking for the line that has the exact same slope. So b is out because it's negative 1.2 and d is out because it's negative 1.2. So now we are looking at A and C. So we want to know which one of these lines passes through 50. Well, if we want to know, we're going to go back over here. I'm going to start a new graph, and I'm going to graph both of these equations and see which one of those equations goes through the point 50. So I'm going to do 1.2x minus 6, and I'm going to graph it. And then I'm going to do another graph, or first of all, I'm going to trace this graph, and I'm looking for the one that goes through the point 50. There's two ways you can do this. 50 means your x-intercept is 5. So I can do the same thing here. If you understand that that means that the x-intercept is 5, I can analyze my graph, look for my 0, and again, I know my 0's got to be 50. There you go. So A is your answer. Here's the other way you can do this. Let's say it gives you some other random point that is not your 0. Let's say it gives you like 4, 3. What you can actually do is you can add a table in there. So if I hit menu, I can go to table and I can go to split screen table. That gives me the coordinates. So when x is 1, y is negative 4.8, and it gives me the coordinates of the graph. What am I looking for? I'm looking for 5, 0. So I can look in my table, and there it is right there. When x is 5, y is 0. So you can use that as well for the table. So that is how you can actually do perpendicular and parallel on the graphing calculator when you're given the equation. Because a lot of times you're given parallel and perpendicular and asked to find equations, and this is how you can use the graph. Just remember, parallel lines have the same slope, identical. Perpendicular lines have opposite reciprocal slopes. So just to give you one more example, if I give you a line y equals 2/3 x plus 4, any line that has a slope of 2/3 x has a slope of 2/3 is going to be parallel. So these guys would be parallel. If I wanted to do perpendicular, if I had y equals 2/3 x plus 4, I would actually have to find the opposite reciprocal of 2/3, which is negative 3/2. I take the opposite and flip it, and that would be a perpendicular line. So you can see the difference between parallel and perpendicular.